we're reviewing for summative number 6. It has on it 2 old things and 2 new things, okay? I can just start at the top and go. You can ask me questions. I may skip around a little bit. I'd like to get as much of this covered as we can, so, but let me know if I'm going too fast. Anybody help me? How do you find an inverse? This is really y, so you do what? Switch x and y. And then kind of think of it as cross multiplying, at least that's how I think of it. So it's x times 2y plus 1, or 2xy plus x, don't lose that, goes 3y minus 7. Then what? We're trying to get y by itself. Which way do you want me to move the y's, guys? Subtract 3y or subtract 2xy? All right, I'm going to subtract the 2xy over here, which means I should also add 7 so that I end up with an x plus 7 on the left and a 3y minus 2xy on the right. Yeah, thanks. What do I need to do? Emma, this is your birthday card. Not really. If I take out a y, factor out a y, that was the whole goal of this. So I'm left with 3 minus 2x. And last thing then is just to divide both sides by that 3 minus 2x. And depending which way you moved, you might get the opposite of all those signs if you move things the other direction. Any questions? Okay, that's a retake section. Whoops, I don't know why I did that. All right, then it asks, is this one-to-one? And you say yes. Passes horizontal and vertical line test. But what does it mean? It asks that, what does this mean? What does one-to-one mean about the function or about the graph? One-to-one means, anybody know? Right, its inverse will be a function. All right, then you are to graph this line and its inverse and write the equation of the inverse. So I hope you can graph a line. Go down 6, up 2 and over 1. Now, you could graph it right now by doing what? Yeah, you could flip all the ordered pairs, right? And graph the inverse. But you do have to write the equation anyway. So if we switch this to x and this to y, how would we isolate y? Add 6 over here. And then we would need to divide both sides by 2. So you could write x plus 6 all over 2. Or normally in this form, we would say there's a 1 in front of the x, so that's a 1/2 x, and 6 divided by 2 is 3. So this one starts at 3 and is going up 1 and over 2. Or you can go backwards. It should, like this one, crossed here at 3 and down here at -6. This one crossed at -6 and here at 3. It should look like they reflected across the line y equals x. Questions? Where I got any of that? All right, so that's one standard, the 1.7. Then there is this new one, 2.1, where you have to graph on your calculator. 3x to the -5. I don't know why I thought I put a picture on here already. So go to y equals, thank you, -3x to the -5th. Do I remember it right now? Except I have two negatives somehow. All right, and if I do a zoom 6, I get this picture. Using the color calculator helps. I don't know, we don't have those in this classroom, but the other thing that might help you is just to trace, because somebody's going to think it just ends, right? Does it look like on yours it just ends right there because it hit the, okay? If you don't have a color calculator, it kind of looks like it ends right there. So just want to trace along and go, oh yeah, it's just getting really close to 0. Do you see what I'm talking about, guys? Okay. The other thing is, if you trace here, you notice it does go past -1. It is in fact getting close to 0, right? For both x and y. All right, so you can just throw, I think it goes through this ordered pair, but I really don't care, just so you can show me the shape. If you went to the table, whoops, wrong way. It has -1, 3, and 1, -3 is about the only two nice ordered pairs. All right, domain and range. The calculator is going to mislead you unless you really graph carefully. So you have to know that the calculator is misleading. As I go left to right, what is the only value that I don't have? 0, right? So the domain is -infinity to 0, but not including 0, and then 0 to infinity. I know it looks like it's like -1 to 1 or something, but it's not. The only gap is at 0. It is getting closer and closer to 0. The range, bottom to top, is the same. The only gap, even though it looks like it hits it on your calculator, the only gap is that asymptote. Does it cross any x or y? No. This one has no intercepts. Is it continuous? Yes or no? It's not, because you have to lift your pencil, right? It has an asymptote. End behavior. Okay. So if I do left and right, that would be x is getting more negative or x is getting more positive. Both on the left and on the right, this is getting close to what y value? 0. All right, and then I know it doesn't, it seems like it's so tiny and whatever, but in essence, you're doing this and you're doing this as you go left to right. So both of those are what? Increasing, but you do have to say the domain interval where it is increasing. So you have to say -infinity to 0 and 0 to infinity. All right. There's another one listed on your paper, and the one on the quiz is likely either like this one or the other one listed on your paper, so I'm going to go super fast through this one. Do you see you have a 2x to the -4th there? How it says it down at the bottom? Am I crazy, or does it say that? Okay, so I'm going to fill it in a chart. I know you don't have a chart to fill it in, but it's positive to, is it negative fourth or positive fourth? Okay, so the graph looks like this. Again, if you trace, it does get closer and closer to zero. It does not stop, okay? I know yours is probably looking like it does. And I'm just sketching really rough because you don't even have graph paper. Okay. Domain, left to right, everything except what? 0. But range, you might get this one on the quiz, guys. Range, bottom to top, what's happening? Everything's above 0, right? So I say 0 and up, not including 0. Everybody all right? This one has no x or y intercepts. It's not continuous. Both the left and right get closer to what? 0. But what's happening? This side is increasing from the left until you get close to 0, and this side is decreasing from 0 to the right. All right, review your notes on those if you need to. There was like 5 or 6 basic kinds of graphs. You certainly don't have to memorize them, but if you're confused about the increasing, decreasing, or the domain and range, kind of study them and make sure they make sense to you. All right. Part of that same standard, okay, the same standard is this radical equation stuff. I'm going to go quick because we need to keep moving, but you would isolate the radical, so you would subtract 5 here. Anybody tell me what you would do next? To get rid of a 4th root, or a 3rd root, or a 5th root, or a square root, you do the power, right? What power do I have to do here, though? To do to the 4th. 256, can somebody check that? 4 to the 4th? Is that right? Okay, so then if I subtract 128, I think I get 128. And if I divide by 3, I don't think it comes out nice. So I think it's just 128 over 3. Did anybody? Okay, so if I put that back in to check it, 3 times 128 over 3 would just be 128, right? And 128 plus 128 would be 256. So I'd have 5 plus the 4th root of 256 equals 9. You could do this. Does anybody know what power that is? 256, the 4th root is also the 1/4 power, if you wanted to type it in that way. Otherwise, you can do 4th root under the math menu. But it is 4, so it does check. All right, this is the kind that sometimes, well, students mess up because it's a pain, but they also sometimes don't check, right? So which one, you have to leave one radical on each side. Which one's going to look nice real quick here? The right side, right? Because it was all under the radical. So it's just going to become x minus 45. What do we have to do on the left, though? There is no shortcut. There's no such thing as distribute an exponent. So we have square root of x minus 3 times square root of x minus 3. Square root of x times square root of x is just x. But here, a minus 3 square roots of x and the outside one are both minus 3 square roots of x, minus 3 square roots of x. And then negative 3 times negative 3 is plus 9. Hofbauer likes to see the fact that there's an x on each side and just divide that out. But I have negative 6 square, not that, just kidding. Negative 6 square roots of x, right? And a plus 9 equals negative 45. If I subtract 9, I get negative 54. I divide by negative 6. I got 9. Is 9 the answer? Okay, let me explain what I did if anybody's lost. I saw there was still a radical, but I wanted to isolate that radical all over again. Does that make sense? So I subtracted 9, divided by negative 6. If it doesn't come out nice, I still can leave it as a fraction and then square both sides again. This one came out nice, but I got 81 this time. If I go back to the top, I'd have the square root of 81 minus 3 equals the square root of 81 minus 45. That would be 9 minus 3 equals the square root of 36, I think. Does that seem okay? That one works, right? But check on the quiz. It could be extraneous, which means it does not check. Any questions? You have another new standard of simplifying rational expressions or solving rational equations. They're all in the same standard. These two you cannot solve. There is no equal sign. Is everybody with me? All you can do is simplify, okay? I'm going to show the work because I really would like you to show the work, but however you're going to explain it, the common denominator here, to subtract or add, you need a common denominator. It would need an m plus 1 and an m plus 5. So right now, this side needs an m plus 5 over an m plus 5, or this expression. And then this one needs an m plus 1 over an m plus 1. So that they now have a common denominator that has both. Okay, the top, I'm distributing a 6m. What do I get? (6m) squared plus 30m. But what's going to happen over here? I have to be super careful because it's a minus, so I am distributing a negative 2m. Everybody okay? So I get a negative 2m squared and a negative 2m. Then when I combine the top, I have a 4m squared plus a 28m. You could factor the top, take out a 4m, but nothing will reduce, so it's fine to leave it as it is. Questions? Just don't lose the common denominator. Some reason, when we do the one in a minute where you multiply through by the common denominator, it has an equal sign, and you get rid of the denominator, then people come back and do these, and they lose the denominator somehow. All right, this one is just factor, except I have to remember to flip, right? Because it says divide, flip that second one over. So I take a 9x out. That's an x minus 5. Did I do something wrong? I see you racing. We okay? All right, I just got... Oh, gotcha. I just thought maybe I made a mistake somewhere. Somebody stop me if I do, because we're recording. 8 and 5 make 13, negative 8, negative 5, make negative 13, 8 negative times negative power 40. I think I factored that right. Now this is the top, so I can take out a 5x squared. Left will be an x minus 1. Denominator is a 9x. Well, can't cancel as much as I was hoping for, but what can I reduce? Guys, I just want you to realize this. We're not going to do it that way, but do you realize you could divide this x out of one of these x squareds, right? Okay? Because this is multiplication, and multiplication, you can divide out any part of it. I would just do this whole 9x with this whole 9x, right? But just so you're aware that it's okay to divide out any part of that. If it's in a parenthesis, it's a binomial, it has adding and subtracting, then you can only divide out if you can divide the whole thing. All right, so I'm left with a 5x squared and an x minus 1 over an x minus 8, unless I messed up. Questions? You can get those? Then there's the tricky ones where you have to multiply through and solve. Multiply through by the common denominator to solve. Okay, what is the common denominator here? 3 and a, everybody good? So I'm going to multiply each of these terms by a 3a. Because that's the same as multiplying both sides by something, right? Which is allowed. As long as we have an equal sign, we can multiply both sides by something. Now, when we do that here, this a divides out. Because it was not an addition or subtraction, we can just a divided by a. Left is a 12. On this, we had a bunch of junk over here, but luckily the whole a just divides out. And so we just end up with that junk up top, a squared plus 4a minus 12. We don't have to distribute anything on this one. What divides out on the last one? The a, so we're left with 1 times 3, or 3. Now we have an a squared, so we need to do what? Make it equal to 0 so we can factor. Everybody okay? So I'm going to subtract this 12 over here. I have an a squared plus 4 a's. Be careful, what's negative 12 minus 12 more plus 3? Negative 21 maybe? Okay. Which factors 7 and 3? We need a positive 4, so a positive 7 and a negative 3, I think. I realize some of you would take much longer to factor, okay? I just don't want to not cover something on the review. So I'm trying to help you and go quick here. If we set this one equal, we get a negative 7. If we set a minus 3 equal to 0, we get a equals 3. So I have 3 and negative 7. Now we have to watch for extraneous solutions, but on this problem, what is the only extraneous thing we can't have? No, actually 3 is okay. If I put a 3 in that denominator, I have 3, 9, and 3, right? What can I not put in? 0. Yep, a cannot be 0, otherwise we're good. It would be a pain to check, but you could check each of those if you wanted. Oh, one more of these, okay. If I factor this denominator, take out an a squared, I'd have an a plus 5. This one has an a squared, and this has an a squared a plus 5. So what should my common denominator have? Everybody good that it needs an a squared and an a plus 5? So I'm going to go a squared minus 8a plus 16 is currently over an a squared a plus 5. And then I have an a minus 3 over an a squared, and I am going to multiply that. And then over here I have a 1 over an a squared a plus 5. And I'm multiplying each one of those by an a squared a plus 5. So this guy, all that drops out, and I don't have a denominator anymore, but I have all this junk on the top. This, only the a squared divides out, so what am I going to have to do here? I'm going to have to multiply those together, right? FOIL them out. So a times a will be a squared. A times the 5 back here will be plus 5a. A negative 3 times this a will be a negative 3a. And a negative 3 times that 5 is a negative 15. I certainly could have rewritten them, as a multiplication. So it was a minus 3 times a plus 5. Looks a little nicer. This side, everything divides out, so we have left equals 1. Okay. Combine like terms. I have a 2a squared. Anybody get minus 6a maybe? Negative 8 plus 5 would be negative 3. Minus 3 would be negative 6. Then I have a 16 minus 15 is 1. Oh, interesting. But I got to subtract a 1 over to that side, don't I? So it's just 0. So how does that factor? This is an interesting one, but yeah. A minus, we took out a 2 though, right? There we go. All right, so if 2a equals 0, we divide and we just get a equals 0. Everybody okay with that? Right, you can divide by 2. A minus 3 equals 0, you would get a equals 3. Okay, can a be 0 and 3? If I go back to the beginning, can a be 0? No, if I put a 0 in here, it would be dividing by 0. So this one is extraneous. A can only be 3. There's a little more practice on that stuff. I put an extra page on the back, and I can tell you in a second which ones would be good to do on those. All right, but then we have the whole fun of transformations one more time. All right, and please stay with me here because I did change some of these, okay? On the next slide, there was a couple that were just way too ugly for what it said. Anybody remember what a negative inside does? Yes, reflects over the y-axis, so it would reflect that way. And then a +2 on the outside is a vertical shift, or just a shift up 2. This one has 3 things going on. Anybody know the order we should say them in? That first, which is horizontal shift left 7. You can just write left 7, especially for practice here. Then the negative, which is reflect over, what's the negative on the outside reflect over? X. It is a vertical change this way, up, down. Reflect over X. And then a vertical shift up 8. It would not, I wouldn't count it wrong if you switched the first 2 around the order, but you have to put the reflection before the shift up. All right, this one is nasty. Probably not something on a quiz, could be on a retake, I suppose, but that 2 is a vertical stretch by 2. Then because we have these parentheses, we don't worry about the negative until the end. So this one has a vertical shift up 5. And then a reflection over the x-axis. You could distribute the negative and describe it a little bit differently, but it's not on the quiz like that anyway. Yeah, go ahead. It's not in the f of x parentheses, so it's not a left-right. Yep, good question. Anybody know what this is? Because I think this concept is on the quiz. Inside here, it affects x's, which is horizontally, but it's reciprocal because it's inside. It's opposite of what it seems. So this is horizontal compression or shrink by 1/4. You could say by 4, but it's like dividing by 4, okay? So I usually say by 1/4. And then this at the back is what? Vertical shift. It's not in the parentheses, so it's up 3. Okay, make sure you know that one. Questions? Right, the next ones are the ones I changed. How much time do we have, guys? Okay, so we're in pretty good shape, thank you. This says a cubic function, which would be an x cubed. Everybody good? Or it would also look like this. Okay, just so you're thinking about where those things would go. Vertical compression of 1/2. Would be on the x cubed, right? That's the a value, that's vertical outside here. Reflect across the x-axis just means it's upside down. So we'd put a negative on there and be done. I took this out on purpose because there's not going to be one that's that complicated. It made it very complicated. All right, well, I don't know that one, anyway, some of them did. I switched this one. Reflect across the y-axis. Where does that negative go? Inside on the x. Vertical stretch by 2. That would be a 2 on the outside. And up 7 would be a plus 7. Again, these aren't necessarily exactly like the quiz, but they were, one was really confusing, so I changed them, sorry. All right, this is on the quiz. Write a new equation for a transform quadratic. So you're supposed to know that means what? What's a quadratic? It's a parabola or an x squared. Everybody okay? So this is our parent function. If it has been shifted left 2 and down 6, or has a vertex of -2, -6, when we put in a -2 here, and a -6 here, we get this, which becomes plus positive. And then if it goes through this point, how do we find the stretch? Put this guy in for x and this guy in for y. Everybody okay? So 24 equals a times 8 plus 2 squared minus 6. Careful, what do we have to do first? I mean, you can take care of this if you want. A times, this would be 8 plus 2 is 10. 10 squared is 100. But what you can't do is 100 minus 6, right? Because this is multiplied together. You could write that as 100a if it's less confusing. You have to add 6. So a is either 0.3 or 3/10. Could you check this on your calculator? I don't know how much time I have, probably not enough, but you can type this in your calculator, right? And you could find the max or min and make sure it's at this point, and you could go trace 8 and make sure it comes up as 24, or you could look at the table. So that's when you can check on your calculator. All right, oh, there is a sketch question. You only have to do one thing to it, I think. But let's talk about this. The first thing here is to flip it upside down, right? The negative out here. So if I flip that upside down, I'm just going to sketch it over here real. This one was at 1, 3, so it would be down here. This one would be here. Okay, there's the upside down. What's the other thing that's supposed to happen? Up 3. So I need to take all those points that I did in red over here and move them up 3. So this one goes up here. This one was down. That's not right. This one should have been over one more. All right, then I was down here at 1, -3. If I move it up 3, it's at 0. Then this one was now at 2, 2. If I move it up, it's going to be at 2, 5. And then this one was at 1, 2, 3, 4, 0. If I move it up 3, it's here. There's only one thing you have to do. You don't have to do 2 on the quiz, just so you know. All right, what's this one do? Because this could be on the quiz. A 2 in there is a horizontal what? Shrink. It divides or takes half of all the x's. So this one was at -4, 1. Half of that x is -2, 1. This was at -1, 1. Half of that x is -1/2, 1. This one was at 1, 3. Half of the x is 1/2, 3. This one was at 2, -3. Half of 2 is 1, so it should be at 1, -3. This was at 4, 0. Half of 4 is 2, 0. What if it had said 2, 1/2 x? You would have doubled all the x's, right? And it would have stretched it out horizontally. All right. This is one more example of finding a stretch. I can go back and do that one in a second, but I really wanted to make sure we talked about these. How do you describe in words what happened from this one to this one? Look at those ordered pairs. X value is what? Multiplied by 2. Everybody see that? Which is a horizontal what? Stretch. Okay, how do you write that in function notation? Where's the 2 go? Inside or out? Horizontal is inside. It doesn't have a name, so you can call it F or G or H or whatever. But do I put 2x inside? I have to do the reciprocal, right? This would be 1/2. Because inside is the opposite of what it seems. And this one, what changed here? The x's didn't change at all, right? The only number that changed was the y multiplied by 2. What is that called? It's called a vertical stretch, which would be a 2 on the outside. I know I went fast. All right, on the last page, just, I think the answers are the answers all at the bottom for the last, okay. Two of them are really ugly. So if you wanted extra practice, I would suggest you stick with 1, 4, 6, 7, 9, or any, you don't have to do any of them, but I'm just saying, there was a couple of them that were just really gross after I put them on there. I'm like, oh, I should have just not even put that on there. All right, should I go back and do this one I skipped? This is a cubic. If it's shifted left 3, it would be a +3 in here. Up 4 would be a +4 on the back, but we don't know the stretch until we put in this XY point. -12 equals a cubed roots of 5 plus 3. This is cubed root of 8. What is the cubed root of 8, guys? So we'd have -16 equals a times the cubed root of 8. This is 2, so we just need to divide both sides by 2. So I got -8 as the stretch. Did anyone else get that? So y equals -8 cubed roots of x plus 3 plus 4. And again, to check that, -8 math cubed root of, what did we have? I already forgot. X plus 3 plus what? 4. Okay. And then we could go to the table, and it was supposed to be going through, what was the ordered pair? 5, -12 is indeed there. And if we looked at, whoa, that's an interesting, it was supposed to be shifted left 3, right? So if I go -3, it is up at 4. That's a misleading thing on the calculator again. I think if I did a zoom decimal, it might get rid of, no, it still looks like it's got a hole. It does not have a hole. All right,